So thank you, everyone. Just right after lunch, I hope not to get you some siesta. I come from Spain. That's a long tradition. Anyway, so yeah, my name is Julio Faura. I was the chairman of the Enterprise Alliance. I was the one of the founders and the founding chairman. I'm not anymore since I left Santander to build my own companies about 7 months ago. I'm also the chairman of Falastria, which is a permission enterprise-grade blockchain network that we launched in Spain. And I'll tell you a little bit about that. And then I also work in a few startups that I lead, and I'm also one of the co-founders of Azhos as well. So I'm going to tell you a little bit about tokenization of money, right? The applications, and a little bit of the technical aspects on how we do electronic money on a tokenized basis over blockchain, and a little bit of the applications in the financial world, right? And I also was asked to talk a little bit about the technical aspects of that, right? The technology that Azhos used is a pure blockchain technology. It's based on a type of Ethereum, enterprise-grade Ethereum implementation. So we're going to be talking a little bit about that. Anyway, I hope it will be more or less interesting. All this concept of electronic money and tokenized money is based on blockchain. And here, the idea of blockchain is to use the idea of decentralization to value. The same way internet disrupted the way of not disrupted, but transformed the world of communications, right? So that's why we say that blockchain does to value what internet did to communications, right? So it's really the decentralization of the value, right? Essentially, when internet was invented, that was at the end of the Cold War, right? So the problem there was that if you have New York here and you have San Francisco here, and in the middle you have Chicago, and all the communications from New York to San Francisco go through Chicago. If an atomic bomb is dropped in Chicago, then you get no communications in the whole country, right? So Chicago becomes the central point of failure, right, of this thing. And you can spend a lot of money into a single point, but if that thing blows away, then the whole thing stops to work. And that's why they invented blockchain, not blockchain, but internet as a way to decentralize communication. So you would surround your node with a few more nodes, then those nodes with other nodes, and then you create a mesh. So then there are a lot of ways to go from one side to the other, right? So now you can get rid of one little dot or another node, or 10%, or 20%, or 60% of the nodes, but you always find a way to get a communication from one side to the other, right? That is very interesting because, first of all, it's very cheap, right? The big dot in the middle, that's very expensive. The small dots on the right are very cheap. So you can, if one doesn't work, then you'll use another one, and that's it, right? It's very cheap. It's very resilient, obviously, which is the big benefit. And the other idea is that it is very simple to access, right? That scales a lot better than that, right? Because you just need to join one of the nodes, and then you essentially are in the network. And that's why internet started to grow and grow and grow, and it's what it is today. Now, in the case of blockchain, we try to do exactly the same thing, but to the concept of value, right? Instead of communications, to value, right? Today, the world is based on silos of or trusted entities that hold the value for us, right? That register the value for us, right? For example, a bank. What is a bank? A bank is essentially a ledger, which is like a database that has some entries like, Julio has this much money, or Marcel has this much money, and you see, it's just essentially a database, right? The thing with that database is that it is very critical, really critical. And then what we have done in banks is we have surrounded that database with a lot of cybersecurity measures, right? When you want something to be safe, what do? You put it on a safe, right? And that's what we've done with the banking ledgers. So the systems in banks have not been designed to be interactive. They have been designed to be safe, right? Very secure. Now, the world works today, of course, but whenever you need two banks or two banks, for example, to interact with each other, it's difficult because those two ledgers are not communicated. And in order to communicate them, it's always difficult. You need to go through an intermediary, or you need to somehow create a messaging protocol to try to do that, right? And it's complicated because it's not designed to be like that, right? The second thing is that the appetite of banks or enterprise actors anyway, I mean, because there are many other enterprise actors that will have something similar to ledgers. Like, for example, a telco company will know how many minutes you have consumed or what is your plan, right? I mean, all these things are ledgers in some form. Their appetite to innovate is very low. Why? Because if I try to make a change within that, it's a big risk. Whenever I try to use a new methodology, a new tool, it is a big risk, because if there's some problem in the ledger, we go to jail. You see, it's very, very critical thing. So the world works today, but first of all, those systems are expensive, right? In big bank I used to work in, we would spend about $6 billion in IT costs every year. And that was mostly to make it secure and to make it compliant, right? And second is difficult to communicate, as I said, and there's very little appetite to do innovation, right? It's very risky. Now, the idea of blockchain is, instead of getting each bank or corporate actor to run their own ledger, the idea here is to use just one ledger. So everybody use that ledger or pieces of that ledger to do their stuff. It's like if my bank has this list when it has how much money I have, right, or all the clients, in the same place, which is the shared ledger, as other banks do. Now, that has some advantages. First of all, the ledgers are in the same place. So now if I want to make a transaction, it's very simple, because everything is in the same place, right? That shared ledger, in order to make it resilient, what you do is you deploy it in a decentralized network, so that thing is hyper-replicated in many nodes, right? Like happens in the Bitcoin network, or in the Ethereum network, and so on. So essentially, the ledger is multiplied many times, it's replicated many times. So again, this has the same advantages as in the case of the internet, right? You can attack one node, you can attack 2 nodes, you can attack 5 nodes, you cannot attack the 20,000 nodes in the Bitcoin network. It's just impossible, right? So it becomes very, very resilient and very performant. The third thing is that this thing works in real time, unlike the banking ledgers, right? And actually, when you try to transact between one bank in one side of the world with another bank in another side of the world, chances are that one bank is going to be closed. So these things work in batches and takes time, right, to transact and so on. On the other side, everything works in real time, right? And the other very good advantage is that that thing is very cheap. Again, because you don't need to spend a lot of money in cybersecurity measures for the individual nodes, because they are not critical. They're not single points of failure, right? That's the overall idea why we think blockchain is interesting for all these prospects. Now, the last thing I would like to say is this idea of introducing smart contracts. Now, a normal banking ledger is very simple, right? It's just, as I said, names or IDs, right, and amounts, right? The case of smart contracts is this idea of composing the ledger not just by numbers, but actually by programs. Okay, so you have a lot of nodes, and all that are hyper-replicated, and what you have in each node is not just a simple database. What you have is a program, right? So in this sense, the program is, the smart contract and the blockchain ledger becomes kind of a shared supercomputer. It's like if we had all access to the same computer, and that computer is hyper-replicated and works in real time for all of us, it's decentralized, and whenever some of us put a program there, then everybody will have access to that program. Now, the beauty of that is that that program is now at the sites of everyone, so everybody can see it, you see, and everybody can transact with that. And anything that happens, everybody will be seeing it, right? What is a program? A program is just data and code. That's what it is. You can use the data to model whatever you want, like, for example, electronic money, right? Electronic money is just a balance that you will have, right, in your account, right? And what is the code? The code can be, for example, the rules to make a transfer. What is a transfer? A transfer is just moving money from one account to another account. So it's just decreasing the amount and increasing the amount. Actually, it can be even seen here. You see the first public balance, that thing that goes over there? That's the data. That's just the different balances for the different users. And the function transfer, as you can see, is just if the balance of the sender is bigger than the amount, then I remove the amount from the sender and I add it to the receiver. A transfer is only that. Now, when you ask me to do a transfer on your behalf, you don't need to ask me to do it. You don't need to trust me that I will do those mathematical operations well. You just have to go there to the blockchain and submit that transaction, right? And if you are the right sender, because you will have to sign your transaction using your private key, then this thing will work. Otherwise, it will not work. You see, we have removed the need for trust in validating electronic money transactions if we implement it using a smart contract over blockchain network, right? And it's all available to everyone. You don't need to trust me because all this thing is open source, right? And you can see it, right? You want to work with that, you read it, you understand it, and then you essentially use it, and that's it. So that is, in essence, a smart contract. The nice thing about the smart contracts is that they are programmable and they can interact with other smart contracts. Now, how can you use it in reality, right, for practical applications? Well, at least in this first phase, what we do is we use tokenization. We implement tokenization, right? Tokenization is a good first step towards a fully digital world, right? Essentially means using smart contracts to represent digitally assets that otherwise live somewhere else, right? I could use the programs to implement digital assets directly, right? But before we go into that, let's do a first intermediate step, which is tokenization. So how do you tokenize electronic money? It's exactly the same thing electronic money works today. You essentially move your money, the client money, to an omnibus account, which is another bank account in the same bank, right? Just move the money from the client to the omnibus account, and then the tokenizer, which is this little blue backend solution, will issue the electronic money as data on the smart contract. So what you have in the smart contract now is a digital representation of the money that is sitting there in the omnibus account. So as you can see, is the same thing as PayPal works. So you have your PayPal wallet, right? You want to fund it. You send money to PayPal, to their omnibus account or their concentration account, as they call it, right? And once PayPal has the money there, then they give you your balance, right? Now, in the case of PayPal, they will write your balance in their internal database, and they will show it to you when you look at your wallet, right? Or they can open an API for you if you convince them or something. So essentially, PayPal is segregating the funds for all their clients, including you, in that database, right? And all the money is pooled in an omnibus account at the bank, which is PayPal's account, right? In this case, it's exactly the same. Except that instead of using an internal database in PayPal, PayPal would be using a smart contract. So it's just a technology choice. We're just using a smart contract instead of a proprietary database, right? From a regulatory point of view, there's a thing or two to say about that, but that's what Simon will tell you later, so I will not spoil anything else, right? Now, what is the beauty of this compared to the normal PayPal way, right? The real benefit is that that smart contract now lives on a decentralized ledger. So now, if I want to interact with my balance, for example, I want to pay it, or I want to put that money on escrow, or I want to use this as collateral to get a loan, or if I want to use this to like trade, right, or something like that. In the case of PayPal, I need an API for PayPal to allow me to interact with that, right? In this case, you just need to be in the same decentralized ledger, write another smart contract, and start working. In other words, money becomes programmable, right? That's the beauty of it. Money is implemented, is legally implemented on a programmable fashion, right? Because it is implemented with smart contracts. And of course, you can create all kinds of permissioning mechanisms, so you make sure that only the people that are legally permissioned to do it can actually interact with those balances, right? You do that at the smart contract level and not at the security, physical security level, all right? The same way you create the electronic money, you can redeem the money, right? So you go to the smart contract and say, hey, I want my money back. So then the detokenizer, in this case, will eliminate the tokens and will send the money from the Omnibus account back to the client account. So it's very simple. You tokenize, you detokenize, right? Very simple. Now, what can you do with that? So, for example, you can make it, you can exchange it, right, for other types of tokens. And the same way you tokenize money, you can tokenize other things. For example, electricity. This is actually a project that was done in Germany. It was Innogy, right, the energy company that did the first version of this. Essentially, what you do is the electricity company in this case creates electricity tokens. These tokens are, again, digital representations of electricity. So when you redeem one electricity token, you essentially get the electricity in return, right? The redemption of money is you get the money in return. The redemption of electricity is you get the electricity in return. So you implement that in a smart meter, in a smart plug, right? And then you can create another smart contract where you create a marketplace, and you exchange electricity tokens for electronic money tokens, right? Why is this a potential solution, or why is this interesting? Well, you know, I live in an apartment building in my city, and I buy an electric car, and I go to the garage, I go to my space in the garage, and I want to charge the car, and where do I plug the car? Because the plug is not mine. I mean, the plug is going to be paid by the community, so I need a way to pay it myself. Otherwise, you know, the neighbors are not going to be happy. So essentially what I need is a coin-operated plug, right? So a simple implementation is just using a Raspberry or some kind of small computer into the smart meter that implements a blockchain node, and then is able to redeem the electricity tokens, for example, right? You only need connectivity through the internet. You don't need to go through the banking network. You don't need to go through Visa, MasterCard, or anything like that, right? And the average recharge in Spain is 5 euros. So you could do it with credit cards. It would be kind of... Anyway, maybe it's not the best example, but at least it's an example on how you can use electronic money to mix it with other digital assets, right? Now, talking about the electronic money itself, and for those of you who are familiar with tokens, ERC20 tokens and Ethereum tokens and so on, essentially what we used is a little bit of an enterprise version of the ERC20 token normally, right? Essentially, we add a few features to that. First of all, the possibility to fund the token. So essentially, you can go and say, hey, I want to debit a bank account. So that thing through the backend module will move the money into the Omnibus account and issue the token, right? The possibility to redeem the token or to pay out the token, right? So I say, okay, I want my electronic money to be transferred to a bank account. So in that case, you call the redemption method with some payment instructions associated to that, so the system can then route your payment. And then the most important 3 new elements are, first of all, the regulation of the token. So only permissioned owners can have token wallets. In other words, you cannot send the money to whoever you want. You can only send the money to people that have been KYC'd by the electronic money company or the bank, right? Second, the possibility to hold the tokens. So essentially, I have my money, and I have a possibility to put some tokens on hold for you, waiting for a transaction to happen. It's like when you go to a hotel and you get your credit card and they do a hold on you just until you finally pay. When you pay, you actually execute the hold, right? The money that was put on hold for you. So it's the same concept here, and we need that in order to be able to process more complex transactions like international payments and other ones. And also the possibility to have overdrafts. So not just positive balances, but actually negative balances as well, and so on. And with the combination of the holding capability and the overdrafts, you can also create collaterals. So you can do collateralized or secured credit lines, which is very practical for funding accounts and things like that, right? Example of an application of this is international payments, right? Again, when you do international payments today, and I'm not suggesting this doesn't work, this does work, but the fact that you have different banks with different ledgers which are separated and can only be communicated through messages makes it a little bit inefficient, right? For example, if I am sending dollars from the US and I want to send some dollars so my counterparty on the European Union receives euros, essentially I need to move some money from my bank account to my correspondent bank account, and I do that through a Nostra account, as it's called, right? So I move the money in that ledger to go to the correspondent bank. Then that correspondent bank will talk to the other correspondent bank and will make a transfer as well, right? And then the correspondent bank will finally send the money to the receiving bank on bank 2 on the right. Now, by the time the money hits there, they are seeing some money that comes from the correspondent bank, but they don't know why, right? Because they cannot associate that to the payment that was being processed, right? Because they don't have the instructions for the payment. And therefore, in order to complete it, the bank on the left needs to send the instructions, ad hoc instructions, to the bank on the right. So the bank is seeing money coming and some instructions coming, and now they have to do reconciliations. They have to reconcile these things. Now, that's a complex process. You need a lot of people in back offices to do that. It's quite error-prone. The banks we work with in Africa, they will do about 85% of the transactions will need some kind of manual intervention. Big banks in Europe, and I'm not necessarily referring to the one I was working with, but some others as well, that percentage is going to be well over 15%. So I'm not suggesting it doesn't work. It does work, but it is a little bit inefficient. The other thing is that every time you make money, you change the money, right, between the banks, the corresponding in the middle, they will have to have money pre-funded, waiting in order to be able to terminate the payment, right? If I'm doing a payment for you to that bank, I need to have some money pre-funded there, and when you give me your money, then I will pay from my money to your client, right? That's what I will do. Now, having money waiting in Nostra accounts, that is expensive because of the opportunity cost of money, right? That is quite expensive. And we have so many correspondents, and with all these cycles, that ties up a lot of capital into the system. And that is quite expensive. When you do that in Europe, that's more or less okay. But then you go to Latin America, opportunity cost of money in Brazil, for example, is 9%. You go to Argentina, it's like 60%. Anyway, better not go to strange places from time to time. But anyway, the other difficult thing with this is, well, of course, the operational cost as well, but also is the service. When your client comes with his or her dollars, it's very difficult for you to tell them how many euros will they make it to the other side, because you don't know, and you cannot say as well how much time is it gonna. Is going to be needed in order to do that. Again, because you just don't know. I mean, the whole cycle takes a few days, right? So it's very difficult as well. So that, in terms of customer service, is not very nice. So what you can do through the tokenized electronic money construct is actually use the same shared ledger to connect all these banks. You can connect liquidity providers, which are the ones that have the Nostra accounts, and you can even connect central banks as well. So you use the same shared ledger to create all these digital money tokens and then create the payments applications as natively digital applications through smart contracts. Let's see how this works for a very simple international payment. Essentially, you deploy one of these tokenizers on the left. Let's say this is a bank in Spain. And you deploy, so the one on the left is Spain and it's euros, and the one on the right is in the UK, and it's pounds, for example. Right? So you have the possibility to create crypto euros and crypto pounds through tokenization processes, as I just explained. Then you can write another smart contract in the middle, which is a payments processor. So essentially, you come and you create the payment as a single digital object in that smart contract. Now, there is a market maker, which is the liquidity provider that holds a Nostra account, in this case, in pounds, for example, on the right? So they will tokenize part of those pounds and will get some crypto pounds on the shared ledger, right, in that smart contract. So essentially, the market maker has some crypto pounds. Then the market maker will be quoting some euro to pound exchange rates, right, into the payments processor smart contract. So we implement an FX book, right, the typical FX book that you find in the capital markets. And so they are quoting these prices in real time, right? Now, when the payment starts, then the bank on the left will create the payment as a digital object on the smart contract. The euros will be tokenized. The crypto euros will be put on hold. That's why we need the hold. The equivalent amount of pounds or crypto pounds will be put on hold as well. So now all the money is ready on hold, ready to be settled. That means that this can either work or not work, but it cannot fail one part and succeed the other one. Right? That avoids what is called the settlement risk, or the Herstatt risk is called, right? Because of Bank Herstatt a few years ago. So at this point, the money is put on hold and the payment is ready to be processed. At that time, the bank on the right will do anti-money laundering, all kinds of checks to see if the payment can be terminated. And if it can be terminated, then it will be settled atomically. At that point, the crypto euros will go to the market maker and the crypto pounds will go out for redemption. Right? So the whole process takes a few seconds. The payment is completely settled end-to-end, and we are using electronic money in the middle, in two places, just to initiate and to terminate the payments and to manage all the liquidity. Then, of course, the market maker now has more euros and has less pounds, so they have to go to the FX markets and do hedging and blah, blah, blah. But you see, we're using the electronic money construct in this case in order to facilitate international payments and do it in real time with a lot more transparency. In more complex situations, you can actually change some of these, right? So for example, imagine that this is a banking group that has a subsidiary on the left in Mexico and a subsidiary on the right in Poland, right? So what these guys can do, they can have a subsidiary in the middle, let's say the UK, which is a very normal place to do something like this. On the left, you would tokenize pesos. On the right, you would tokenize zlotys. And in the middle, you would tokenize dollars, for example. Then the treasury on the left can just do market making between pesos and dollars, and the treasury on the right can do market making between zlotys and dollars as well. And then when you do the payment, essentially you tokenize the pesos, the treasury will buy the pesos and sell the dollars, the other treasury will buy the dollars and sell the zlotys and work like that, chaining all this liquidity. What's the benefit of that? Is that then the market makers don't need to have Nostra accounts with each other. So if I am the Mexican treasurer, I just don't need to care about the zlotys, right? Today, many subsidiaries will have Nostra accounts with everybody. So if I am Mexican, I don't know about the zlotys. I know about dollars and I know about pesos, but I don't know about the zlotys, and I don't want to know about that. And the guys in Poland have exactly the opposite problem. So you see, with this construct, you can simplify a lot all the relationships that these subsidiaries have today with other banks. They can reduce the number of Nostra accounts they have. They can reduce the amount of liquidity that they have in all these different pockets around the world. You can concentrate that amount of liquidity in one single place, in dollars, or in euros, or in pounds, or something that you can hedge against, and therefore you can reduce a lot the amount of liquidity that you need. And that means big capital savings, right? Big capital cost savings. So, and the other very nice thing is that you can also consolidate a lot all the corresponding banking relationships that the subsidiaries may have, right? You can just get all the flow into the hub and then leverage a much better commercial relationship with your commercial bank, right? With your correspondent bank. Anyway, these are the type of things you can do with electronic money. Of course, if instead of using one subsidiary as a kind of an internal reserve system, you actually use a central bank, that's even better, right? Because you can tokenize as well money if you are a central bank. Suppose that you are either a central bank or a special purpose vehicle that has a reserve account at the central bank. You can use that central bank as a reserve account, right, as an omnibus account, and then you can create the tokens on the smart contract. Now, those tokens is exactly like electronic money. The only thing is that they are backed by central bank money and not by commercial bank money. Therefore, they are universal. They are more secure, you can say, but at least they are universal. So we can get different banks in different jurisdictions to trade with each other through the tokenized central bank construct. So essentially, you have is a very cheap implementation of our reserve account system. A reserve account system is something that is not cheap. This is actually very efficient. So for smaller central banks, it's actually a very good solution. And also the connectivity that this has to the rest of the financial system can be very, very simple. You see? So it's just all different variations of the same theme, right? The next step would be just trying to go a little bit away from tokenization and try to start creating digital assets on top of the blockchain natively, right? This is a real project we are doing in Spain, and it's the creation of a bond, right? Of a corporate bond that is natively implemented on a smart contract, right? The bond is not tokenized, right? We're not issuing the bond on paper and then tokenizing it, right? And then creating a token which is a digital representation of the bond on paper. We're not doing that. We're creating the bond originally, natively, as an annotation on a registry on a smart contract. So we're essentially using a smart contract to act as a registry. Now, the law says that if you want to do that, you have to have a central securities depository license, right? So you have to be regulated. So essentially, the registry is a smart contract that is controlled by a CSD, a central securities depository, right? So again, the same way I was telling you that PayPal can use a smart contract instead of an internal database to do the segregation of funds in tokenized money. You can do the same, or the CSD can do the same, and instead of using a registry that they implement, they can use a smart contract as a registry. Again, it's a technology choice, right? They control the smart contract. They don't control the blockchain, but they do control the smart contract through cryptography. So when you do it like that, then the bond is registered there and is implemented natively as a smart contract. Now, this bond is denominated in tokenized money. It's not denominated in euros. It's denominated in tokenized euros. And the tokenized euros live on the electronic money token smart contract I was telling you about before. So what is the secondary market? The secondary market is just exchanging cash tokens for bond tokens. That's it. The smart contract that implements that, 100 lines of code, well, maybe a couple hundred. I mean, it's not difficult to do, and it's visible to everyone. For example, I don't need to demonstrate best execution, because the execution of that trade goes through the order book smart contract. I mean, the market is smart contract, and everybody can see it. You don't need to trust me for best execution, right? I mean, best execution is actually guaranteed because of the code of the smart contract. That doesn't mean that I should get rid of the intermediary in this case, because That's market smart contract where the trade happens, right? That's a market. It's a market where there will be liquidity providers providing prices, right, for the bonds, and there will be people willing to buy and people willing to sell, right? If I am a buyer, you're a seller, we want to trade, we don't have a bilateral contract. We have a contract with the market, and we need to have a contract with someone in order to precisely guarantee best execution and on all these things, right? Do we need an owner for that contract? Regulation says that, yes, we do. So we make that contract in a way that is controlled and can be managed, right, by the stock market in this case. But eventually we could say, hey, what is the value that the stock market is bringing to us? Because everything happens automatically in that smart contract. So why do we need someone to control it, right? The code is visible and the blockchain works. And the answer is, yeah, I mean, if the blockchain works, then we don't need an intermediary. But if it doesn't work, then what? We need someone to sue if this thing doesn't work. And that's the reason why we still need someone responsible, right, for each of the smart contracts. Otherwise, we'll have to start changing the law. And we don't want to be able to, or to need to change the regulation, at least in this first phase. Maybe later on, at some point, we can think differently. But what we are doing, essentially, is trying to use blockchain and smart contracts to support the current regulatory frameworks, including electronic money, which is what we were talking about, including electronic money, banking money, capital markets instruments, whatever it is, right? Now, the nice thing about all these things is that they are programmable, they are universal, and you can use it for many other things. The example with the electric car is just one small example, right? But when you mix the tokenized money with supply chain evidence, then you get something as special as Azhos, right? You're essentially bringing everything together and creating applications that are built natively on smart contracts as digital single objects, and that's very, very special. Anyway, I think I'm going to stop here. I was going to tell you, well, there are many more applications, but I don't think we have time for that. I was going just to tell you a little bit about how you can implement this on blockchain networks that support the smart contracts. The most widespread technology that supports smart contracts in this way, so they are really available for everyone and so on, is Ethereum. And I was going to tell you a little bit about the different aspects that conform a good enterprise-grade offering of blockchain technology, right? Essentially, is the possibility to do permissioning. So in other words, to make sure that you know everybody that participates in the blockchain network, and you permission, someone permissions all the people that participate, so not everybody can just go and join and do whatever they want, right? Performance, the original blockchain implementations, including Bitcoin and even Ethereum, have very severe limitations when it comes to performance. Only a few transactions per second, maybe 10, 15. With enterprise-grade blockchains, we can go to hundreds, if not thousands, of transactions per second. I'm guessing Kieran that will tell you later about enterprise great Ethereum implementations will speak about this. I've personally configured a quorum network in more than 10,000 transactions per second. Not that we need it for anything, but anyway, what I'm trying to say is that this is not a problem anymore. Confidentiality, the possibility to make some or all of the transactions, the amounts on the transactions, and also the private information you want to share on the blockchain confidential, so just available or just visible to a few of the parties, right, that are involved in a particular transaction, which is very important. For example, when we do international payments, okay, you create the tokens and blah, 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 but then you need to share, for example, the payment instructions, right? And the payment instructions have the personal information of the person that sends and the person that receives. You don't want that to be on the blockchain available for everyone. You could even encrypt it and put it encrypted on blockchain, but then everything will grow massively, because all these things, even if they're encrypted, they will be replicated hundreds of times or thousands of times if you have a lot of peers, right? So you need ways to to exchange this information only between peers, right? And now there are ways to do that through private channels, through sidechains, through anyway, through a variety of different mechanisms, and also privacy. The idea to use encrypted information through zero-knowledge proofs or through homomorphic encryption and range proofs, which is really technology we're using to do something like that. And finally, the most important one, which is actually the need for responsibility and governance. Blockchain was designed to be ungoverned, right? Completely trustless. Meaning that if I want to start mining as another Bitcoin miner, I can just buy the hardware, put it, and nobody can stop me, right? If I try to cheat, then the rest will just ignore me. But nobody can censor me, right? Those networks, the public networks, are uncensored, that they're uncensorable. In the case of enterprise applications, you need a way to actually concentrate the responsibility somewhere so someone can guarantee the blockchain service, right? If I am going to segregate client funds, I'm going to issue electronic money on the blockchain, I need to have a contract with someone that guarantees that the blockchain works, you see, and if it doesn't work, then there will be penalties, indemnities, or whatever it is, but they need a, you see, I need a responsibility framework. And if the network is completely decentralized and completely so if there is lack of accountability, then I will not be able to guarantee that, right? So it's very important to have, first of all, good permissioning technology, which we have already, so we can at least make someone responsible for that. And then we will need either a distributed responsibility legal framework, which means that I'm signing terms and conditions not with just one party, but with several of them, or the idea of concentrating the responsibility into just one vehicle that then can have SLAs for validation purposes and blah, 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 right? But governing all that and having the way to clarify the responsibility framework and governing it is one of the major topics that we've encountered when we start to use these things in real production settings, right? I was going to tell you some details about that, but I don't think we have time. We do have good enterprise technology nowadays to do these things, and these things are really growing a lot. They are benefiting from all the work done in the community, but they are taking this to enterprise-grade status, right? Block apps, that's the one, the fourth one. Well, they will tell you a little bit about that in a minute, right? Finally, just a very quick mention to Alastria. Alastria is a blockchain network that we launched in Spain. Essentially, we decided to create a public network, but permissioned and regulated, right? So we created a non-for-profit association that runs or fosters the collaboration between all the different members to create an enterprise-grade blockchain network with a clear responsibility framework. It's got more than 300 members, including all the major banks, all the energy companies, Telefonica, all the government agencies, the Securities and Exchange Commission, the Bank of Spain, the Treasury, Spanish Treasury, startups, universities, a lot of people. It's already got dozens of nodes, and that's I think is the first time that we tried to do this, the idea of creating a general purpose, multi-sectorial blockchain network to do stuff on that on a permission and regulated basis. We're not there yet, but we're making a lot of progress. I think I'm going to stop here. I could be like talking forever, so I don't know if there's any question. Any question or?
I would say it's fair enough to say like one question is okay, and then we need to.
Yeah, and the break.
All right.
There's one over there. Or?
Is this the death of Swift?
So I wish I got a penny for every time I get that question. I don't think it's the death of Swift. When we do international payments, like I was explaining here, right, or there, It is true that if you do things like this instead of like that, you don't need messages, right? So here, there's no single version of truth when it comes to the payment, right? I mean, you send the payment, you ask the bank on the left, where's the payment, and they will tell you their truth. You ask to the other one, and the other one will tell you their truth. So there's no a single sherd of truth, and in this case, there is, right? Because the payment is created as a single digital object on blockchain, and what is the status of the payment? You just go and look it up, right? Because you cannot fake it. So it is true that when you do things like that, you don't need a Swift message. However, you do need to run that ledger. Because of the responsibility framework, you need someone to be responsible for the blockchain network, not for the payment applications, not for the smart contracts, but for the basic blockchain network, right? So my personal crusade on this is to get Swift to be the owner of the blockchain network. And if you take the bylaws of Swift, which is a Swiss cooperative, you can see that their mission is to build connectivity networks for banks. And that is what a blockchain is, right? So I think it's a great role for blockchain, actually, to guarantee the ledger that could be running the validators, running the consensus mechanism, and so on, and just permissioning other people banks, through their private network, to deploy their networks, and their nodes, and then deploy their blockchain applications, the smart contracts, and so on. I think there is a role for Swift. Because if we don't have Swift, then we'll have to get someone to control the network. And if it's someone, then we're creating a single point of failure, right? Because that party can be corrupt or can have a technical problem or something. So the next best is creating a cooperative, right? A vehicle that is governed by an array of people. But you know what? I mean, we already did that years ago, which is Swift. And it works, governed by the bank. It works great. Great team, great technology, and they would be a great owners of the blockchain network. Again, not the applications, but the network. So I don't think this should be the end of Swift. I think this is a very good opportunity for Swift to actually expand their business into something else and over time transform it. Because at some time, the messages have to go away. I mean, the messages is like, something we have to get rid of.
Thank you very much, Julio.